Look at this math I did in the last video about derivatives, which I will link to the side and down below. This is a lot of math to solve for the derivative of the function x squared, which we eventually find out is just 2x. Now imagine you wanted to do this for more complicated polynomial functions. That would be a real pain and a lot of work. But no worries, there is an easy solution for all this. In calculus, we have something called the power rule. The power rule essentially lets us take the derivative of any polynomial function. I'm going to show you the rule here, but if you'd like to see the proof for it, either look on Google or search in your textbook for it. The proof is very similar to the math I did in the last video about derivatives, except it proves it for all polynomial functions. Suppose we have some function x to the n, where n is a constant. This represents a polynomial function. ddx just means take the derivative. So if we wanted to take the derivative of x to the n, we would say that it would be equal to n times x to the n minus 1. Remember that long example of taking the derivative of x squared? Let's do it again with the power rule. This 2 corresponds to n, and the x obviously corresponds to x. So we would say that the derivative is equal to 2 times x to the 2 minus 1. When we simplify, we just get 2x, which is obviously the same answer that we expected. Now let's take a more complicated polynomial function. Let's say 3x to the 6 plus x to the 4th plus 1/3 x to the 3rd plus 7. The way that we would take the derivative of this is by separating this function into multiple smaller functions of x. And then we take the derivatives of the parts. We can rewrite the derivative of 3x to the 6th as 3 times the derivative of x to the 6th, and then just use the power rule. And this would give us 3 times 6 times x to the 6 minus 1, or 18x to the 5th. Then ddx x to the 4th, which would then give us 4 times x to the 3rd. We would do a very similar thing to the first example, pulling out the 1/3, and then taking the derivative of x to the 3rd. We would get 1/3 times 3 times x squared, or just x squared once we simplify. And then there are a couple ways we can take the derivative of a constant like 7. We can rewrite the expression like this, 7x to the 0, which is the exact same thing, and then use the power rule. Then we would bring down the 0 to get 0 times 7 times, it doesn't matter what else, because 0 times anything will be 0. Or you could think of it like this. Since the derivative is the rate of change, and a constant does not change, we could say that since there is no change, there is a 0 derivative. And then we put all the parts together to get the answer of 18x to the 5th plus 4x to the 3rd plus x squared. And really quickly, I'm going to touch upon the exponent differentiation rule. This rule is not as common as the power rule, but if you'd like to find the proof for it, same thing, either look on Google or check in your textbook, which I highly recommend you do because it helps you get a better understanding of the rule as a whole. The rule states that if you have some function a to the x, which is an exponential function, and we take the derivative, we would get that it is equal to a to the x times the natural log of a. So if we take the derivative of 2 times e to the x, we pull the 2 to the front and get 2 times e to the x times the natural log of e, which is just 1. So our answer is 2 times e to the x, which if you notice is conveniently the exact same answer as our original function. Say we wanted to take the derivative of 7 to the x. We would say that is equal to 7 to the x times the natural log of 7. And that's all you need to know to understand the basics of the power rule and the exponent rule when it comes to differentiation. If you enjoyed it, feel free to like and subscribe. Thank you for watching.